Thank you all for coming to this session. It's called Revolutionary Learning Technologies. I'm Scott Traylor, Chief Kid of 360 Kids, a company that specializes in developing content and technology products for children. With me today, I have Walter Bender, the president of One Laptop Per Child. We'll first start off today's presentation with Walter Bender, and I'll hand the podium over to him.
Okay. I'm the president of a trade association, actually, a nonprofit trade association called One Laptop Per Child. And this is our mission. We want to develop a low-cost laptop so that children around the world, particularly in the developing world, can have access to computation, because we think it's a real key to education and to learning. And probably what you've heard of is not One Laptop Per Child, but the $100 laptop. Our goal is to make a laptop computer that only costs $100. We're probably going to be around $135 coming out of the box next year. Within 2 years, we'll hit $100, and hopefully within 3 or 4 years, we'll be down around $50. So this is who we're targeting, all those kids who are left out, and this is where they live. Our launch, which is going to be first quarter next year, is probably going to be in the countries in green: Argentina, Brazil, Nigeria, Egypt, India, China, and Thailand. Although we're expanding that a little bit. And we hope to ship between 5 and 10 million machines next year. It all starts with learning, and that's really why we want to get these children laptops. No matter what the problem is, learning, I think, is central to the solution. And actually, my colleague, Negroponte, has a brother who works in Washington here, and Nicholas likes to quip that to his brother John, you try to make peace your way, I'll try to make peace my way. So the question is, how would you design a laptop for children? Here are a few of the things that we think we're focusing on. It's got to be safe, it's got to be robust, particularly in this environment. So we're making it with extra heavy plastic, we're making it be moisture and dust proof. At the same time, it's got to be light. It's got to be sort of kid-friendly. It's got to work outdoors, and it's got to work indoors. And it's got to help them not just use the laptop in isolation, but help them communicate with each other, with the teachers, and with the world. And in particular, it really has to encourage them around expression, and I'll get into that in a few minutes. We think that computation is a great vehicle for open-ended discovery. And of course, because of the market we're trying to serve, it has to be inexpensive. Kids are mobile, and learning is something that happens as part of life, not just part of school. That's one of the reasons why it's a laptop. There have been a lot of computer programs in schools where the computers get locked in a closet, and that's not what we're after. We really want the computation to be in vivo, part of their lives and part of their community's lives, part of their family's lives. One of the things we've done on the technology front, my colleague Mary Lou Jepson has invented display. A display is the most expensive component in a laptop. Her display costs about 25% of the cost of a typical display, and it works both indoors and outdoors in sunlight. Networking is also key. A lot of places we're going they don't have infrastructure, and so the laptop out of the box will provide infrastructure. It'll provide a peer-to-peer infrastructure. One of the problems that we face is that a lot of the internet, when it was actually first designed, was peer-to-peer, but it sort of evolved into a client-server model. And the client-server model doesn't work if you can't get to the server. And again, in the audience that we're trying to reach, they can't always get to the server. So if you wanted to chat, for example, and you can't get to the AOL server, or the Google server, or the Yahoo server, or whatever, you're out of luck. And you can't let the kids be incumbent upon these remote resources, so we set it up as a peer-to-peer access. So out of the box is a cloud of connectivity. Another challenge we have is power. Typical laptop, I don't even want to think about how much power this laptop consumes, but the typical laptop consumes probably between 20 and 40 watts. We're targeting 2 watts. And one of the reasons, again, is because in 50% of the places we're going, there is no electricity. And so electricity is going to have to be generated, and in particular, it's going to get generated by hand by the kids. In fact, I was at a meeting this morning, and another meeting tomorrow. We're having sort of a beauty contest on female power systems right now, and I think sort of this bulwarker-like thing's probably going to win. We also designed the laptop. We use nickel metal hydrate, because it's not because it's more efficient, but because it's more tolerant to weird voltages. In fact, there's even some evidence that if you put weird voltages into nickel, you get extended battery life. And we know that people are going to build their own solutions in terms of providing power for the machine. So we wanted to be able to build something that was safe and respectful of that. And finally, we're building the laptop around an open source model. This is going to be the most open computer in recent memory. Even the BIOS is going to be an open BIOS and all the device drivers as well. And the reason for that is we want the children to be able to completely appropriate the machine. And they really need to own it. And the teachers and the children have to be able to reshape this thing. Because again, Nigeria is one of our targets. How many languages do you think they speak in Nigeria? Any guess? How many? 10? 11. 320. Okay, and there's just no way that we from the top down are going to be able to service that. It's got to be a bottom-up effort, and that's just one example of localization and local culture we've got to account for. I mean, I was actually visiting the school in Yucatan one time, and a colleague of mine, same experience in Senegal. In both Yucatan and Senegal, you know, the indigenous counting system is not base 10. And so in the Yucatan, the kids go to school and they learn base 10 in Spanish, even though at home it's base 20 in the Indian languages. And in Senegal, it's base 10 in French instead of base 5 in their native languages. There are all these aspects of localization and acculturation we have to take into account. So how are the kids going to use the laptops? They're going to be consumers, but they're also going to be creators. And so a lot of our emphasis is not just on downloading and consuming content, but having the kids create their own content. In this case, I'm using an example of the metaphor, the iPod versus some technology that came out of my old lab at MIT called HyperScore that lets kids compose music. They're also going to learn to learn. They're not just going to learn stuff, they're going to learn to learn. And they're going to do that primarily through debugging. And we're pretty much convinced that you learn through doing. And if you won't learn through doing, if you believe that assertion, then if you want more learning, you want more doing. And so how do you facilitate more doing? And so a lot of the epistemology around what we're doing with the laptop is all about facilitating doing. So this is an example of a project we did down in Brazil. The children, instead of just playing Dance Dance Revolution, built their own Dance Dance Revolution machine. And you have to share, you have to communicate with each other, you have to communicate with other people. One of the real problems that teachers have in rural settings is they're isolated, they're alone. And they don't know everything they need to know. So giving the teachers and the children an opportunity to share experiences, help each other debug and problem solve, and reach outside of the constraints of their local community is fundamental to how we think this is going to work. The laptop has a number of different modalities. We actually refer to it as a Trojan horse sometimes. The horse is the e-book. It sort of unwraps into an e-book. And that's attractive to a minister of education because they can distribute more widely text. But the soldiers inside the horse are the children themselves. And again, our idea is that an e-book, and this is an example of a wiki that I set up for the project. In an e-book, you have an article. There's the article namespace. Okay, that's the received knowledge, whether it comes from the teacher or from the publishing community or whatever. But the nice thing about a wiki is there's another namespace called discussion. And so the children can annotate, have a discussion, augment the material directly within the context of the tool. And there's also something called protect. Now this page is protected, so there's an unprotect button, and I happen to be logged in as myself. I'm the one who protected it. So you don't have to associate wiki with anything goes. In fact, you've got all these different layers that you can control. And so the idea, though, that knowledge goes out there in a form which can be sacrosanct, but at the same time it can be appropriated is again, central to how we're approaching the project. And then the other thing is that books and texts don't have to be passive, they can actually be active. And this is a project by Alan Kay, who's working with us. It's called Logowiki. He was really frustrated when he went to look up about the logo language in the Wikipedia, and there was all this beautiful logo code that he was reading on a computer, but he couldn't execute it because it was static. It was like a book. So we've taken the metaphor way too far. We've lost the notion of computation. So he rewrote something called Logowiki, where it's a wiki, it's a book, it's a way of distributing content at the same time it's active. So you can hit run and actually see the logo code execute in this book, and you can change it in this book. So why am I here? I'm making sort of this is version 0.1, so I'm actually looking for some feedback on this, but basically this is a call to content creators, educational publishers, for example, to think about providing materials for this audience and for this machine. And we're particularly interested in K through 12. We're interested in support for multiple languages, and we're interested in free content licenses, much like the Creative Commons licenses. And we're interested in a wide variety of materials. And we want to be able to reach these kids. And it's all about the children, and with that, I think I've used my 15 minutes. Thank you.